Good morning, everyone. I'm Dr. P. Saravanan, and I will be handling your chemistry lab session this semester under the course code BS1108 Physics Chemistry Lab. This course is a part of Regulation 2021 syllabus and follows the choice based credit system, which means students get flexibility in choosing subject and developing core skills. In this lab, we will be performing a set of physics and chemistry experiments that are essential to understand the fundamentals of science through hands-on practice. In this lab, we will explore a variety of experiments that connect theory with the practical knowledge. You will learn how to handle instruments, carry out titration, and understand chemical properties and reaction through hands-on work. We will be doing 6 experiments as per the syllabus, but I will explain the major 5 today so that you can understand the aim, principle, and simple step for each one. Please note that this is the combined lab course physics chemistry. So you will be attending physics lab and chemistry lab on alternate weeks. For example, if you attended chemistry lab this week, you will go to the physics lab next week and it will continue like throughout the semester. The detailed schedule will be informed by your class counselors. Please follow the schedule strictly and be present in the correct lab at the correct venue. Each lab, which means a physics and the chemistry lab, carries 100 marks, which means physics lab 50 marks and chemistry lab 50 marks, total 100 marks. These marks include your performance in regular experiment, record submission, viva, and model practicals. So your attendance, active participation, and submission of record on time are very important for your internal marks. Before we start with our chemistry lab session, I want to make sure you will follow some important rules and regulations. These are not just formalities, they help maintain safety, discipline, and a good learning environment. Be in time. Please make it a habit to arrive on time or a few minutes early to the lab. Being punctual helps you stay relaxed and ensure you don't miss any important instruction at the beginning. Starting on the time also helps the entire session run smoothly for everyone. Next, move on to the second point, be in proper dress code. Please make sure you wear your white color lab coat every time when you enter into the chemistry lab. It helps to you safe, clean, and professional while working with chemicals and instruments. Wearing the lab coat is part of our lab routine, and everyone is expected to follow it. Next, move on to the third point, complete manual and record. Always being your lab manual and updated record book to every session. Having your procedure and previous calculation ready show your preparation and helps you perform the experiment confidently and correctly. Being well prepared is the first step towards success in the lab. Next, move on to the girls tie hair. All girls are kindly requested to tie their hair neatly before enter into the lab. This is important to keep your hair safe and out of the way while handling instrument and chemicals. It also helps to you work confidently and avoid any distraction during the experiment. Next, move on to the last point. More than 3 absent in the regular lab. To write the model practical exam, you need to attend all lab regularly. Please try to attend all the lab sessions so that you are fully prepared and confident during end semester practical. Coming to the lab regularly help you practice well and learn better. So please take these instructions seriously. They are meant for your safety discipline, and smooth progress in the laboratory session. You will be guided and observed during each lab. So, following these rules and regulations will help you build good lab habit and ensure you complete the course successfully. Instruction for writing the chemistry record notebook. When you write record notebook, write heading like aim, principle, procedure using black color pen. Write the main content like this paragraph, procedure paragraph, all are using blue color pen. Then draw the table, graph, and diagram neatly using pencil and ruler. You can use both side of the record notebook. Left side of the record notebook, write calculation, tabular column, diagram, and observations. On the right hand of the record notebook, you must write aim, principle, upper test record, procedure, and research. Maintain the neat handwriting and proper spacing. Do not use any whitener or any scratches line. Strike mistakes happen neatly with the single line. You must write aim, apparatus, principle, and procedure before performing the experiment. Get your record signed by the faculty after each experiment. We will choose five of these experiment for practicals. For each one, I will explain the aim, principle, steps, calculation method. Please make sure to attend all sessions, maintain your lab manual neatly, and come prepared. These are the list of chemistry experiment. In this chemistry laboratory course, you are required to perform any six experiment from the list prescribed under Regulation 2021. Each experiment help you understand an important concept in chemistry through hands-on practice. Now, let me briefly introduce the experiment we will be working on. First experiment, determination of total temporary and permanent hardness of water by EDTA method. And before going to start the experiment, first you have to know about some primary concept of hardness. Hardness is due to the characteristic properties of water sample which do not lather or form easily with the soap solution. This is mainly caused by the presence of calcium and magnesium ions. Then next move on to that temporary hardness. Temporary hardness due to the presence of carbonate and bicarbonates of calcium and magnesium ions. And permanent hardness due to the presence of chloride and sulfates of calcium and magnesium ions. And total hardness due to the total hardness means sum of temporary hardness and permanent hardness. In this experiment, we are going to estimate the amount of temporary, permanent, and total hardness by using given water sample, and you are provided with a link solution or standard solution of EDTA. What is the basic principle involved in this experiment? This estimation is based on the complexometric titrations. Ethylene diamine tetraacetic acid forms stable complexes with the calcium and magnesium ions present in the hot water sample. This is a well-known complexing agent, and the well-known complexing agent is readily complex with the calcium and magnesium ions which are present in the water sample, and they may convert it into complex. Then the complex EDT is a well-known complexing agent which are readily complex with the calcium and magnesium ions, which will readily give us a stable complex of steel blue color. And before going to start the experiment, first we have to know some important basic principle involved in this. The hot water is buffered to a pH of about 9 to 10, and aerogram black tea indicator is added, and the indicator combined with the calcium and magnesium ions in the hot water form an unstable complex of wine red color. First, The EDT indicator is readily complex with the calcium and magnesium ion, and it will give us V complex. And the V complex is targeted against EDTA solution which are taken the burette. Uh, in order to get better result, we have to maintain the pH value around 9 to 10 by adding ammoniacal buffer solution. After the titration, we can get stable complexes of steel blue color. As the EDTA is added, the free calcium ions and magnesium ions complex with the EDTA, these complexes are more stable than the indicator metal ion complex. When all the hardness causing ions are complexed by EDTA, the indicator is set free, which gives steel blue color. Temporary hardness is due to the presence of dissolved bicarbonates or calcium and magnesium ions, and it can be easily removed by boiling. On boiling the bicarbonates of water, on boiling the bicarbonates present in the water get decomposed and precipitated out, and it is filtered out. The filter contain permanent hardness, and it is estimated by EDTA method. Procedure titration 1. Titration 1 is otherwise called as standardization of EDTA. Standardization means we are going to find out the unknown concentration of the given EDTA. Pipette out exactly 20 ml of standard hard water taken in a clean conical flask and add 5 ml of ammoniacal buffer. They are used to maintain the pH value around 9 to 10. Why we should maintain the pH value around 9 to 10? Because in order to get stable complexes of steel blue color. So that we must add 5 ml of ammoniacal buffer. Then we need to add 2 to 3 drops of EBT indicator. When we add 2 to 3 drops of EBT indicator, the hard water solution may change into wine red color. And then wine red color complex is readily tracted against EDTA, which are taken with burette. The endpoint is disappearance of wine red color into appearance of steel blue is the endpoint. Repeat the titration for concurrent titer value. Titration 2, estimation of total hardness. Pipette out 20 ml of sample water in a clean conical flask, then add 5 ml of ammonia buffer to maintain the pH value around 9 to 10. And you need to add 2 to 3 drops of same indicator. And the endpoint is also same. And disappearance of wine red color into appearance of steel blue when we try to take the pink wine red color into standard ETT solution. From this final formula V1 divided by V2 into 1000, we can get total harness. Next, I move on to the third iteration, estimation of permanent harness. Pipette out 20 ml of boiled water in the clean conical flask. Then you need to add 5 ml of ammoniacal vapor. Then need to add 2 to 3 drops of EBT indicator. The endpoint is color change from wine red to steel blue. From the final equation V3 by V1 into 1000 ppm, we can get permanent hardness. Next, move on to the calculation part. This part almost student has to write in the left hand side on the record. You always need to observe the calculation part, reading, enter the reading, graph, and model graph. It is there. It will be worked out on the left hand side of the record notebook. Citation 1, standardization of EDTA. EDTA versus standard hard water. The indicator is EDT. This is the tabular column. And then this table is used to write down your reading, citation reading during the experiment. Let me explain each column. First, serial number 1, 2, 3. Each citation you perform is listed as a new entry. Next, volume of standard hard water in ml. This is the volume of the known solution you take in the pipette, usually 20 ml on the experiment. Next, move on to the burette reading, initial and final. Initial reading is the volume in the burette before you start adding the solution. Final reading is the volume after you stop the titration when the endpoint is reached. volume of cycle EDTI column, and this is the difference between the final and initial reading. It tells how much solution was used to reach the endpoint. You must do at least three trials and, and write all the values. Once you get two or three consistent, which means same or nearly same values, those are called concurrent values, and you can use the average of this calculation. For example, I will explain one example. Initially, you will take 20 ml as standard solution using pipette. Then suppose you filled with the burette with acid 0.01 ml, and after titration it is stopped 12.3 ml. Initial reading is zero point 0.0 ml. Final reading is 12.3. This is the volume of solution used from the burette. So final minus initial 12.3 minus 0.3 equal to 12.3 ml. How to identify the concurrent value? Now look at here, 12.3 ml and 12.3 ml are same values, and 12.4 is very close. So you say 12.3 and 12.3 are the concurrent values matching the reliable. This is the standard procedure. You must follow all volumetric titration. I have explained it in detail now, so it will not be repeating it again. During the upcoming titration based experiment, please make sure you understand this method clearly and follow the same step for all similar experiments. Since all volumetric titration follow the same format, I have explained it completely here. From the next iteration experiment onward, I will not repeat this step. So please apply the same procedure carefully. Do not assume the concurrent value mean or an average. First, identify the matching reading. You must perform at least three titration. Out of this, if two or more title values are exactly the same or very close, usually within plus or minus 0.1 ml, they are called as concurrent values. So concurrent value is not a mean value or average. They are the matching or repeated values that indicate your titration is accurate and repeatable. After identifying the concurrent values, you should enter them on the respective column. Then 1 ml of standard hard. Next, move on to the calculation part. 1 ml of standard hard water contains 1 mg of calcium carbonate. So 20 ml of standard water contains 20 mg of CaCO3. So from the final step, we can calculate the strength of given EDTA solution. This is the tabular column. From the tabular column, we can calculate estimation of total hardness. This is the calculation of total hardness by using this formula. From the final formula, we can calculate the strength of total hardness. Yes, from this final equation, V2 divided by V1 into 1000, we can get total hardness in ppm or mg per liter. Titration 3, estimation of permanent hardness. From the table, we can calculate from the table and the calculation part, we can calculate the permanent hardness. Yes, this is the step. By the way, we can calculate the amount of permanent hardness which are present in the given water sample. Yes, from this final equation, V3 divided V1 into 1000, we can calculate the permanent hardness. Next, I'll move on to the calculation part of temporary hardness. Temporary hardness can calculated by using this simple formula: total hardness minus permanent hardness, so that we can get temporary hardness present in the given water sample. After the calculation and after taking the reading and calculation part, then you have to enter the reading answer part in this research column: total hardness, permanent, and temporary hardness. Determination of chloride content of water sample by absorptiometric method. Aim of this experiment to estimate the amount of chloride ion present in the given water sample by absorptiometric method or Morse method. Basic principle involved in this experiment is simple precipitation titration. Natural water has sodium chloride, potassium chloride, calcium chloride, and magnesium chloride, and the total chloride content in the water sample should around 250 ppm. Chloride ion with K2Cr2O4 as indicator form yellow color solution, not precipitate. This yellow color solution is treated against silver nitrate solution and form AgCl as a white precipitate. When all the chloride ions are removed from the solution, AgNO3 form Ag2Cr4 is a reddish brown color precipitate with the K2Cr2O4, which is a reddish brown color precipitate. Apparatus required for doing this experiment: burette stand, porcelain tile, 20 ml pipette, funnel, conical flask, 250 ml conical flask, porcelain tile. Then procedure involved in this titration. Titration 1, standardization of silver nitrate, which means we are going to find out the unknown concentration of the given silver nitrate solution. That's why it is called as argentometric method. Prepare 20 ml of standard sodium chloride solution in a clean conical flask and add 3 drops of potassium bromide indicator. Titrate the solution against the KgNO3 solution taken in the burette. The endpoint is the color change from yellow solution into reddish brown color precipitate. Repeat the titration to get the concurrent values. Yes, this is the yellow color solution when we add indicator to the sodium chloride solution, which are treated against silver nitrate solution, which are taken in the burette, which is changed into the white color mass, which is called as silver chloride, which is react with the potassium chromate indicator, then may converted into reddish brown color precipitate as a endpoint. Next, titration 2, estimation of chloride content in the water sample. As I said before, pipette out 20 ml of exactly 20 ml of sample taken in a clean conical flask, then add same indicator like potassium chromate as an indicator to the water sample. Titrate the solution against silver nitrate solution, which are taken in the burette. The endpoint is also same, color change from yellow to reddish brown color precipitate. Repeat the titration to get the concurrent values. Let's move on to the calculation part. From this point onwards, students have to write on the left hand side of the record. From the table, we can find out the volume of silver nitrate which are used to neutral the NaCl solution. From the calculation part, we can calculate the strength of AgNO3 solution by using V1N1 equal to V2N2 formula. Titration 2, estimation of chloride content of the water sample. Here we can titrate against standard AgNO3 versus water sample. Here we have to use indicator as potassium chromate. From the table and the reading, we can calculate the amount of chloride ions which are present in the given water sample by using this formula. From this V1N1 formula, we can calculate the strength of water sample. Strength of water sample. From the strength and equal weight, we can calculate the weight of chloride ions which are present in the given water sample. Yes, from the final equation, from this final formula, we can calculate the amount of chloride ions present in the given water sample. Strength of given water sample plus equivalent of chloride into 1000, we can get amount of chloride ions present in the given water sample. Finally, you have to write down the result on the respective column. It will be around 250 to 300 ppm or mg per liter. Next, the third experiment, estimation of HCl using sodium carbonate as primary standard and determination of alkalinity in the water sample. Aim of this experiment to determine the types and amount of alkalinity given in the water sample, and moreover you are provided with a standard solution of HCl. What is the basic principle involved in this estimation of alkalinity? Alkalinity in water sample is due to the presence of soluble hydroxide, bicarbonate and carbonate. Determination of various types and amount of alkalinity is easily carried out by titration with the standard HCl employing the indicators like phenolphthalein and methyl orange independently or successfully. The titration of water sample against a standard acid to phenolphthalein endpoint shows the completion of hydroxide alkalinity and one half of carbonate alkalinity present. On the other hand, titration of the sample against a standard acid using methyl orange endpoint make the completion of the reaction 1 to 3. The possible combination of ions is OH ions only, bicarbonate only, carbonate only, or both hydroxide and carbonate together, and carbonate and bicarbonate together. Total amount of acid consumed is used to measure the total alkalinity. OH and bicarbonate ions cannot exist together since both the ions combine intensively and to form carbonate ions. Similarly, carbonate, hydroxide, and bicarbonate cannot exist together. Procedure, titration 1, standardization of HCl, which means we are going to find out the unknown concentration of the given HCl. So that you have to pipette out 20 ml of standard sodium carbonate into a clean conical flask, add 3 drops of 2 to 3 drops of methyl orange indicator. Now the solution tone in yellow color. The yellow color mixture is studied against HCl which are taken in the burette. The endpoint is disappearance of yellow color into appearance of pale pink color. From the formula V1 N1 equal to V2 N2, we can calculate the strength of given HCl solution. Titrate the solution against HCl solution taken in the burette, and the endpoint is the color change from yellow to pale pink. Repeat the titration for concurrent titer values. Then titration 2, standard HCl versus sample water. Pipette out exactly 20 ml of sample water into a clean conical flask. Then you need to add first indicator, name is phenolphthalein. You must add 2 to 3 drops phenolphthalein indicator, and then followed by you need to add second indicator, name is methyl orange indicator. When you add phenolphthalein indicator, you can get disappearance of pink color. When you add second indicator methyl orange, you can get pale pink color into pale pink color is reappear. The endpoint is a disappearance of pink color for a phenolphthalein indicator. Into the same solution, add few drops of methyl orange indicator, and the solution changes into yellow in color. Continue the titration till pale pink color reappear by adding the same HCl without break. Titration is repeated till you get concurrent titer values. So result from the tabular column and calculation, you can calculate hydroxide alkalinity, carbonate, bicarbonate, and total alkalinity. This point onwards, students has to write in the left hand side of the record notebook. formula table. These are the three, five kinds of possibility.
Start.
If P equal to 0, which means phenolphthalein endpoint is 0, the alternative due to the presence of only bicarbonate. The remaining ions are not possible. One more example, if phenolphthalein endpoint is equal to methyl orange endpoint, the alternative due to the presence of only hydroxide, the remaining carbonate and bicarbonate is not possible. And next one more example, P equal to half of M, and the alternative due to the presence of only carbonate and the remaining ions are absent. Like it will continue so on and so. And the titration one, standardization of HCl from the title value, concurrent values concurrent value and the calculation part, we can calculate the strength of given HCl solution from the formula V1N1 equal to VTN2. Titration 2, estimation of alkalinity from the tabular column from the concurrent value and the calculation part. We can calculate how much amount of hydroxide and bicarbonate are present in the given water sample. Let us consider if P greater than half of M, the alkalinity due to bicarbonate, carbonate ions. These are the formulas. From the formula, we can calculate the amount of hydroxide and the carbonate. After the calculation part, then you need to enter the reading of the respective column. Hydroxide alkalinity and as ppm, and carbonate, bicarbonate, and total alkalinity. Total alkalinity means combination of all the two ions. Next, I move on to the fourth experiment. Determination of strength of given hydrochloric acid using pH meter. It is not volumetric analysis, it is electrical experiment. Then before going to start the experiment, I need to give some small introduction about the pH. pH is negative log of base 10 of hydrogen ion concentration. pH scale is pH scale is a set of number from 0 to 14, which is used to indicate whether a solution is acidic or basic or neutral. Acid have pH less than 7, bases have pH greater than 7, and neutral solution has pH equal to 7. Aim of this experiment to determine the amount of given hydrochloric acid solution by sodium hydroxide using pH meter, and you are provided with a standard solution of 0.01 N NaO solution. Apparatus and chemicals required for doing this experiment: burette, pipette, 100 ml beaker, funnel, a glass rod, pH meter, glass electrode, wash bottle, standard NaO solution, given acid sample, and pH meter, not conductivity meter, pH meter. This is the pH meter. From the column, we can get the pH value of the given solution. It is a glass electrode, it's a combined electrode. This is a setup for doing the calculation, for taking the reading. Yes, this is a setup